Last time we talked about the efficiency comparison using traditional mechanical cooling as seen here with the lake and seawater cooling. And just to reiterate, we're saving over a million kilowatt hours a year. So if you think about being, say, about 10 cents a kilowatt hour or even 5 cents a kilowatt hour, you're saving $100,000, $50,000 minimum a year on just your kWh. Your fresh water is also being reduced again by millions of gallons as well. Now that you're thoroughly convinced, let's walk into the water temperatures and find out what we want to use. So worldwide, this is a nice map. This is again made from NOAA, and they provide these maps that basically show the world surface water temperature of the oceans. Here you can see that the obvious is stated. It's warmer around the tropics, and then as you go towards the poles, it gets colder. And you can see at the scale at the bottom is all in Celsius. The other thing I'll point out is also whenever you have shallowness, it also gets warm, such as with the Persian Gulf. Here it's listed at 36, up to 36 degrees Celsius, which is 96.8 Fahrenheit. So it's bath water. Whenever we're talking about trying to use that, good luck. Probably not going to be the best or most efficient system. All right, in the United States, NOAA keeps track of all the surface water temperature along the coast. So if you have a boat or something like that, you're going to be able to go and look up that day, that particular hour, what the surface water temperature is. And again, it's pretty obvious here. This is taken as a snapshot in April, but you can see that it's in the 40s along Washington State, Seattle area, go down to Oregon, we're into the 50s, and then down the coastline into California, the 50s get higher and higher. Same happens on the East Coast. We start in the 50s up in Philadelphia and New York, hitting the 60s around North Carolina, and then the 70s by the time we get to Georgia and Florida and in the Gulf region. They also keep track of a lot of other spots as well, such as Bermuda out here. You can see some of the islands as well. You can zoom into those and get a good idea. The Great Lakes are also tracked, and you can see some of these are not available at this particular time that the snapshot was made, but they keep track of all the major sites, and you can start to look at what those temperatures are going to be. And here in April, it was already in the mid 40s, mid higher 40s for the Great Lakes, a lot of the Great Lakes there. Now, for the rest of the world, well, the U.S. has 5,000 rivers. We'll talk about that. They have these monitoring stations all over, and the requirements vary state to state. In Europe, now, what they've done is coalesced around river basins. So the countries that are involved with a particular river basin, say the Danube, for instance, they will have to cooperate with one another. So the Seine might all be in France, for example, but the idea is they are responsible for that. Other countries that might have impact will then have to work together to figure out how irrigation levels are going to be done, as well as all of the other river uses that go along with it. In Asia, 35 major rivers. In Central Asia, they have India is the main actor there, and they have the River Boards Act. And then in the Far East is China, and they have their State Environmental Protection Administration. In Latin America, currently is regulated per country, but they're starting to coalesce, similar to what Europe has done. So they're really following what the European groups have done here, all the nations there, and they're monitoring, regulating to become more uniform so that they don't have sort of extremes as you go from north to south. All right, in the United States, you can see all these river points here all the way across, about 5,000 or so that they are keeping track of actively, all these dots. Now the yellow, orange, and red dots, that means that something is going on with those particular locations. Not that it's necessarily indicating that there's an issue. It's not necessarily flooding or anything like that. It's more of an issue with the monitors themselves. You can see that the purple is also an indicator of something. Most likely that the yellow are maybe not calibrated. Orange might be offline, and the red are just missing, for instance. No signal whatsoever. So we have a lot of data from NOAA, and we can use that data to our advantage to find the temperatures in the United States of the rivers and lakes. In Asia, I'll point out here again, China pretty much controls everything that's going on here, including what happens upstream and going downstream into Indochina. So Laos, Cambodia, etc., isn't having as much of a say on things as China is. And if you followed the news recently, you realize that they've done a lot of irrigation. And because of that, the levels of the Yellow and the Yangtze, the two major rivers in China, have been basically taking a lot of different uh, water uses out. Because of that, the water levels have been very volatile, up and down depending on the season and the place, and just what the rainfalls are. So all these irrigation levels that have been trying to irrigate all of these dry, arid lands up here, up towards Mongolia area, and they're having herds up there and they're trying to keep it going. They're starting to run their rivers a little dry. India, Pakistan, Bangladesh, they've been keeping track of their rivers as well. And in India, river life is very much a part of their culture, so they're very keen on keeping things going there as well. In Up in Russia and towards Europe, basically Russia has the control of all of the rivers that are up there. Not too much else to discuss there, but they do, as you get more towards Europe, they do have more of a kind of comprehensive discussions whenever it concerns water. And the same happens actually in the Middle East. Whenever it comes to water, it seems that all of the sides can settle in and discuss water a lot more easily than they can discuss a lot of other issues. Mostly because they know what their needs are. They can usually be met if they start to agree with one another on how the water should be used, say around the Tigris and Euphrates. All right, EPA in the United States, they have a set of regulations that they installed in 2012. So you might think of the EPA as being this heavy-handed regulatory authority, and that's really not true. The EPA tries to set standards, tries to put limits on all the things that the industrial and manufacturing and power plants can use, and then they have try to set basically like a framework or a path of standards for the state EPAs to follow. And they finally passed some legislation in 2012, and this, for existing facilities, impacted about 1,260 facilities in the U.S. that use over 2 million gallons a day. So if you think about that, it's there's a lot more facilities that are using a lot less per day. And you can see here I have the numbers for 590 are manufacturing plants, 670 are power plants. This is happening currently, but just because this legislation passed doesn't mean that they're always following that legislation. And there still are a lot of violations prior to this and after, whether it's to do with temperatures or whether it's to do with chemical changes or shifts in the water that's being used. And this is where the Justice Department and the EPA settle out of court, usually with different facilities. And it sometimes has to do with, say, stormwater management, like a wastewater treatment facility. Just they get overwhelmed if they can't handle things. And basically they'll settle out, figure out what they're going to do. But they try to put these limits on for 2 million gallons a day for those facilities. For new facilities, one of the things that they put in is a reduced flow, no matter who you are, what you're doing, how big, etc., of 0.5 feet per second, or negotiate fish impingement limits somehow. In other words, they're just looking to not have the fish live in the pipe or they'll be able to swim away out of the pipe. Most fish species that are a concern in North America can easily negotiate 0.5 feet per second. I've worked on projects where it wasn't necessarily the fish that they were worried about. They were worried about the pumps and how much damage the pumps would take from, say, just different critters or different things finding their way into the system itself. So the EPA set this limit at 0.5 feet per second, and that's at the inlet. Now, a lot of other groups you can open up the inlet so that speed is not going to be really a problem to meet. You just keep opening it up until you get to your certain circumference, and essentially you're meeting the requirement. Also, an application for a permit is required no matter where you go, no matter who you are. Again, you need a permit, and usually this is pretty easy to get. It just takes your time to go and get it. You have to state what you're going to use, what you're going to do with the water. And as soon as you do, a lot of the states are very willing, especially if you're a business, a commercial business, they're very willing to work with you to figure out how to make your site more efficient. If you explain all the things that we're going to be talking about here, they're usually pretty easy going about it. Now, there's other design limits to be negotiated, and this depends on your usage. So if you have 2 to 10 million gallons per day, you're going to be facing certain limits. If you're over 10 million gallons a day, which is pretty high, you're probably going to raise a lot of eyebrows. There's probably going to be state legislatures involved, etc. For a facility like that, they have different limits for that as well. But most of the time, there's just a limit on the percentage of the flow of the source. So if you're using it from a lake, usually you're pretty good. A lake volume is pretty high as compared to a river volume. River volume is going to have millions of gallons a day that's going through it. Now, if you're going to take 100,000 gallons out of a million gallon a day or a million gallon an hour river, they're going to question that. And they're going to say, wow, that's 10% of the water that you're using, and you're changing the temperature on it, say 8 to 10 degrees Fahrenheit or even higher. That might cause a problem. But if you're near a major river, or if you want to just use less of that source, you could probably negotiate that with the EPA. And again, that's where they become really easygoing, especially if you're going to tell them exactly what you're looking at. And even though you might have a small stream or river, if you tell them how much you want to use and what you want to use it for, they might give you some limits of what you can use per day, per year, those kinds of limits. And then if there's low rainfall, that's the other thing. They might ask you to use less, for instance. And then the last thing is they'll ask you to demonstrate minimal impact to the organisms and the environment. If you're a small facility under 2 million gallons a day, this is really easy to meet. If you're between here, you need to just demonstrate how you're essentially walking through your entire system and showing that you're not going to be harming the system or harming the ecosystem that you're working with. And this can also be demonstrated by using a lot of material from wastewater treatment plants. That's what they do, and you can do the same thing. You're not having to reinvent the wheel on this particular issue for that. So there's a lot to be negotiated there. All right, next topic we'll discuss oceans, ocean water temperature and depth.